Hi guys, welcome to today's video. This is the video for Tuesday, March 31st, and I'm really excited because I just finally feel like I got the whole, a more complete understanding of how your textbook is laying out this chapter that we are going through right now. So once again, I've retweaked the PowerPoint, and I know that I sent you a copy of the PowerPoint yesterday for you to follow along with, but I'm sending you another one today because I think this one is better. So and that's just my fault, and I'm sorry for the presentation being so choppy and kind of piecemeal. This is what happens when I don't, when I've never taught from a chapter, and I know, like directly, and I don't go through the whole chapter and get it all laid out and then present it to you. I'm kind of presenting it to you as I myself go through the chapter. And so the way that they had things organized wasn't exactly clear to me at the beginning, but now I finally get it, and I'm sorry. But I would rather be a little embarrassed and offer you a good PowerPoint and a better understanding of the ideas and how they flow than try to limp through the one that I had. Good news is I've made very few changes to, I don't think I've made any changes to the internal content. Like none of the material that nothing that I've told you is like not correct, or there's not a bunch of changes within the body of the PowerPoint. It's mostly just a change in the headings so that I think the way that the material's organized makes more sense. So let me show you what I mean. Okay, so here's the newly revised PowerPoint. And I'll try to take you through real quickly the part that we've already touched on. So this is chapter 15, and the very beginning is the same as what we've already gone through, what we went through before spring break. So no changes there about what is evolution and what's the difference between, is evolution just a theory, and how do we define it? Okay, then we got to this part where I presented Darwin's works, and I presented natural selection as one of the means that is one of the processes that's involved in evolutionary change. And that's true. Natural selection is a process involved in evolutionary change, but your book doesn't really expound on that here for the purpose of explaining one of these processes. They really just want you to understand Darwin's contribution, and that's what I didn't get at first. So, I mean, I knew they wanted you to understand his contribution, but I didn't know, like, why they talked about selection again in just a few pages and explained it all again. So I finally understand that what they really want you to get here is not so much all about selection, but all about Darwin and his contribution. So, sorry. So all that to tell you that the title has changed, but none of the material inside has changed, except that I don't have a number 1 by this anymore, because selection as a process of evolutionary change will be enumerated later. So this is really just Darwin's contribution. So changes in slide titles mostly here, no new content since Darwin. So you see a change in title here because this is everything that happened after Darwin. And then your book starts explaining the 5 processes of evolutionary change. And you can see selection, where's my little, is here. And so they are going to expound on Darwin's ideas. But first, they're going to talk to you about something Darwin didn't know, and that is how did variations arise that selection could act on. So, and of course, we know now that mutation is one of the processes that gives rise to variation. So they go through these 5 processes, mutation, selection, gene flow, genetic drift, and non-random mating, one by one. And that's what I'm going to do. Now, I already went through mutation yesterday with you. So these slides, again, the difference is in the title, not in the content. So all of these slides are talking about mutation. And we ended here. And the point of this slide was just to show you that in all kinds of different populations, you experience an accumulation of mutations within the population over time. And that's important to the theory of the evolutionary theory, because it's these mutations that lead to variations, which give the raw material for evolutionary change as it's defined in this chapter. Okay, so then we come to the second evolutionary process, which is selection. And again, we know that this was Darwin's idea along with Wallace, and they observed that populations can contain a lot of variations in a lot of different traits. So there's hardly any a population of organisms where the traits are super uniform. And we now know that those variations come from mutations, but then when you select for particular variations, you can create new phenotypes within your population. And this selection can be artificial, or it can be natural selection. And the first thing your book does is go through some examples of artificial selection. So they talk about how if you start with a wild mustard plant and you select for different traits of the plant that are attractive to you, then you can get a number of different lines from the same common ancestor. So for example, cauliflower, cabbage, and broccoli are all descendants from the wild mustard plant. Of course, we know how much Darwin loved his pigeons, and he was able to show us that all of the crazy different varieties that he talked about in his book were descended from the ancestor, the rock pigeon, and all that had to happen was within the rock pigeon population, there might be a rock pigeon that's born with a variation where it has a fluffier tail or a curved beak or different types of coloring or feathers around its head. And the more that you selected for that trait, you chose to only selectively breed the organisms that had that trait, then you could come up with a number of different varieties of pigeons that all descended from that single common ancestor. Laboratory experiments have demonstrated the same type of effect. So there was an experiment done where scientists looked at the number of abdominal bristles on fruit flies in culture, and in the original population of the fruit flies that they started with, the number of bristles at the end of their abdomen was usually around 40. And what they did is they just kept breeding the flies like we did in class. And when they came up with when they found flies that due to mutation had an unusually low number of bristles or an unusually high number of bristles, they would choose to let those be the flies that got to mate and have offspring for the next generation. And over a number of generations, they found that they came up with new combinations of alleles and therefore new phenotypes that weren't present in the original population at all. So the original population was around 40. They developed a whole new population that had a low number of bristles and another separate population that had a high number of bristles. So again, just trying to show you the effect of selection on leading and how selection of different varieties can change the allele frequencies within a population and lead to new phenotypes, which anytime you change the genetic makeup of a population, your book, that they define that as evolutionary change. Okay, another aspect of selection that's just really related has to do with not artificial selection, but natural selection. Natural selection, when nature gets to choose which traits are passed on and which get kind of, which are the most fit, it tends to lead to an increase in beneficial mutations. And this is simply just because if you have a mutation that's not allowing you to be more fit for that particular environment, what we would call a deleterious mutation, then that individual is going to be less likely to survive and reproduce and pass on their alleles to the next generation. So those alleles that were created because of a mutation that led to that the allele causing the organism to not be as fit as it should be, that deleterious mutation can be lost from the population. When a favored trait evolves through natural selection, we call that favored trait an adaptation. And scientists also use the word adaptation to describe the process that produces the favored trait. So that's a word that you hear a lot in evolutionary talk, that, you know, an organism adapted to its environment. And what that means is that through natural selection, a trait evolved that made the organism more fit for its particular environment. Okay, so that's selection. We've done mutation and selection. We have gene flow, genetic drift, and non-random mating to talk about in the future, but I think that is all my time for today. So let me see if I can turn this off. Okay, you guys have a good day, and if you have any questions or anything, let me know and I'll help you. Bye.